Welcome to qnawire.
Hello, in this question we are given some statements and we have to determine if they are true or false. The first statement is every uh, whole number is a multiple of itself. This is true. Suppose n is a whole number, we can write n as n times 1. So n is a multiple of itself, though trivial, but still n is a multiple of itself. The second statement is it is possible for an even number to have an odd factor. This is true. To see an example, note that 6 is equal to 2 times 3. Now 3 is the odd factor of the even number 6. Now the third statement is it is possible for an odd number to have an even factor. This is false. It is not, yeah. Suppose n is a odd number and it has an even factor. So suppose n is odd number, n equal to n1, n2, where n1 is even. This implies that 2 divides n1. But if 2 divides n1, this means that 2 divides n1 times n2. But this implies that 2 divides n. But since n is odd, 2 cannot divide n, and we reach a contradiction. So if n is odd, it cannot have a even factor. So the third statement is false. The fourth statement, every two different primes numbers are relatively prime. This is true. Suppose P1 and P2 are two prime numbers and P1 is not equal to P2, and suppose they have a common factor n, that is there is n which divides P1 and there is n which divides P2. Since P1 is prime, the only factors of P1 are 1 and P1, and so either n equal to 1 or n equal to P1. If n equal to P1, this implies that P1 divides P2, but the only factors of P2 are 1 and P2. This since P1 is not equal to 1, since P1 is a prime, P1 must be equal to P2. So if n equal to P2, this implies that P1 equal to P2. But this is a contradiction since we have assumed that P1 and P2 are distinct. So n cannot be equal to P1. So if n there is a factor, so the only possibility for n is 1. This now we have proved that any common factor of P1 and P2 must be equal to 1. This implies that P1 and P2 are coprime. The next statement is if 7 is a factor of n, then n is a multiple of 7. This is true. If 7 is a factor of n, that is 7 divides n, then n is a multiple of 7. Okay, so if 7 divides n, then we can write n as 7 times whatever is the quotient we get whenever we divide n by 7. But then n is a multiple of 7. From this equation, we can see that n is a multiple of 7. In fact, this statement is like a tautology. N 7 divides n is equivalent to saying n is a multiple of 7. So this statement is true. The next statement is 34.597. The next statement is 34.597 has 345 whole tenths in it. Has 345 whole tenths in it. This is true. A whole tenth means a 0.1, and this means that if we divide this number by 0.1 as a quotient, we will get um, 345, or the quotient we will get will be sorry, if we divide this number by 0.1, the quotient we will get will have an integer part which is greater than equal to the quotient we will get will have an integer part which is equal to 345, and this is true. As we can see from here, this number is equal to 345 times 0.1 times 0.1 plus 0.097. So this is the remainder when we divide this number by 0.1, and this is the integer quotient 6, so this is true. The seventh statement is 23 has 230 hundredths in it. This is false. 23, when we divide by 0.01, which is a hundredth, we will get 2300. So 23 has 2300 hundredths in it. So the given statement is false. The eighth statement is in base B there are B minus 1 different digits. This is false. In base B there are B different digits. In particular, the digits are 0, 1, 2 up to B minus 1. There are B digits here, including 0. So 9. These are the digits needed for a base 7 place value system. 0, 1, 2, 3, 4, 5, 6. This is true. In base 7, if you want to represent any number in base 7, we would need the digits 0, 1, 2, 3, 4, 5, 6, 7, as we said just here. Now, so the last statement is for whole numbers, any two-digit numeral in base 5 represents a smaller number than the same two-digit numeral in base 20. Yeah, this is true. Suppose we have a number, a two-digit number. Suppose we have a two-digit numeral in base 5. It is represented like this, and the same two-digit numeral, but with respect to base 20. Then this number, second number, is greater because this number translates to b plus 5 times a, while this number will translate to b plus 20 times a. So this number will be bigger than this number. This completes the solution to this exercise question. I hope this is useful. Thank you.